Welcome back, everyone. We are on the back page of simplifying polynomial expressions. Okay, so we are finishing this up with our second video. When factoring trinomials, we examine a specific format of the trinomial ax squared plus bx plus c, where a is equal to 1. This is going to be very big as we go forward. In order to factor a trinomial, you must find two numbers such that when you multiply them and get c, and when you add them, you get b in the formula above. It is fun to think of these as puzzles. So, I like to do the x method, right? So here's an example. X squared plus 3x plus 2. We make a little x. You put this last number, 2, on top, and you put the middle number down low, 3. And what we do is we think of two numbers that multiply together to get the top number, but add to get the bottom number. Okay? So multiply to get top, add or subtract to get bottom. Okay? So numbers that multiply to give me 2 are 2 and 1, and they will add to 3. So then, therefore, I make my two sets of parentheses. The first terms are x and x, and then these two numbers right here are what you put beside them, plus 2, plus 1. Now, what is factoring exactly? Well, if I FOIL this back out, x times x gives me x squared, x times 1 gives me 1x, 2 times x gives me 2x, 2 times 1 gives me 2. Wouldn't you know it, I end up getting exactly what I did to start with. Factoring and FOILing are the opposites of one another. Okay, so it's a good way to check yourself if you need to. So let's try a few of these problems out. X squared plus 8x plus 15. I'm going to make my little x. I put this number on top. I put the 8 down low. And I say, what numbers multiply to give me 15, but add to 8? So 1 and 15, they add to 16. That doesn't work. But what about 3 and 5? 3 and 5 work. 3 times 5 is 15, and 3 plus 5 gives me 8. I do my two parentheses. I go x and x. And I put plus 3, plus 5. Question for you. Do you guys think it matters if I do plus 5 or plus 3, like it reversed it? Well, let me ask you this question. What's 2 times 5? 10. What's 5 times 2? 10. So it doesn't matter which order you put these in, as long as you have the correct numbers in there, you're all set. Number 2, x squared minus 9x plus 20. Okay, so here I put a positive 20 on top, a negative 9 down low. So I'm looking for numbers that multiply give me 20, but add to negative 9. So, okay, 1 and 20 don't work. 2 and 10, no. But if you play around with it for a little bit, 5 and 4 add up to 9, but I want a negative 9. So I can make these negative, negative. Because negative 5 times negative 4 gives me positive 20. So x and x. Negative 5 and negative 4. You're all set. Okay? Now, number 3. Before you can factor, you want to get it in standard form. So I'm going to rewrite this. All I'm doing is flipping these around, which you can do. Go back to my x. Negative 18 up top, 3 down low. Numbers that multiply give you negative 18, add to 3. So we're looking at a positive 6 and a negative 3. Okay. X plus 6. X minus 3. You're all good. All right. We are going to get a ton of practice with this because we have to get good at it. Now, sometimes trinomials are not in this convenient form where a is equal to 1. If a does not equal 1, then we try to factor out a GCF. So a GCF is the greatest common factor. It's what goes into everything. So look at this example. It's kind of crazy. 2x to the third y plus 12x squared y plus 16xy. The GCF is a 2xy. all three of these terms have a 2 that can go into it, an extra x, and an extra y. So if you take a 2xy out, I'm left with x squared plus 6x plus 8. Now we just do the factoring that we did before with just what's inside the parentheses. 8 and 6, 4 and 2, and we get what's inside there. Okay? Alright. So let's try a few of these out. 8x cubed minus 56x squared plus 48x. Now, I'm going to look at this and go, what number can go into 8, 56, and 48? Well, the highest number that can go into all of them is 8. X cubed, x squared, and x. All of them have an extra x. So if I divide each of these three terms by 8x, I'll be left with x squared minus 7x plus 6. Okay, I just divide each of these three terms by 8x. Let's see here. Now I'm just doing what I did before inside this parentheses. 6 is up top, negative 7. What numbers multiply to give me positive 6, but add together to give me negative 7? Negative 6 and negative 1. Okay. X and x. Minus 6. Minus 1. Boom. You just let the 8x chill out front. Okay? Now for this next one, it looks really scary. Okay? Well, I'll give you a big hint. You start with the number out front. Negative 0.6. I can take that out of everything. So if I take out the negative 0.6, the first term becomes x squared. Let's see here. Negative 2.4 divided by negative 0.6, I get a positive 4x. 19.2 divided by negative 0.6, negative 32. Okay? For the sake of this class, moving forward, whatever number's out front for a trinomial, that's what you're looking for, okay, for your GCF. Negative 32 up top, 4 down low. What numbers multiply give you negative 32, but have the 4? Let's see here. We're looking at positive 8, negative 4. Negative 0.6 chills out front. There we go. Looking good. Now, please note, what do you guys see is different about number 3 compared to 1 and 2? Well, there's only 2 things, okay? So I'm not going to be able to do my x method. I can only do the x method with a trinomial, which is 3. But here I have a binomial. So all I'm looking for here is a GCF. What number can go into 25 and 35? 5. And is there a variable that can go into x squared and x? Sure, just x. So if I take a 5x out of 25x squared, I'm left with 5x. And if I take a 5x out of 35x, I'll be left with just a plus 7. What's really nice about that one is if I multiply this back in, I can do a quick check. 5x times 5x is 25x squared. 5x times 7 is 35x. Okay? Excellent. Okay, on to our back page then. Let's see here. Sometimes you might come across a special type of polynomial called a difference of squares. So x squared minus 25. Alright, so what we can do here is I can still do my x method. I can put a negative 25 up top. And how many x's do I have in this problem? Hopefully you guys can see that I have 0 x's. There's no x's whatsoever. Can you think of any numbers that multiply to give me negative 25 but then add to 0? Well, what's the square root of 25? 5. So 5 and negative 5 can multiply to give me negative 25, but they will add to 0 as well. Okay? So let's look at a few examples down here. Number 1, y squared minus 100. Put negative 100 up top, 0 down low. What numbers multiply give me negative 100, but then add to 0? Well, positive 10 and negative 10. So make my 2 parentheses. I can do y plus 10, y minus 10. There you go. So I just realized up here from my review problem that I didn't show you guys the answer. X plus 5, x minus 5. Sorry about that. Number 2, what perfect square can go into 9x and 9x squared minus 36? Well, what we could do is look for a GCF. Okay, a GCF here would be 9 can go into both of them. Okay, so negative 4 can go up top, 0 down low. What number times itself will give you negative 4? 2 and negative 2. Let the 9 chill out front. X plus 2, x minus 2. Okay. Finally, number 3, what number can go into 8 and 50? Well, you can take a 2 out. I'm left with 4x squared minus 25. All right, this one's a little trickier, and there is a shortcut for this one as well. Since it's a perfect square, can you guys all see that 4 and 25 are both perfect squares? What is the square root of 4? 2. What's the square root of 25? 5. And you put plus or minus, and you're all set. All right? So again, we are going to get just a ton of practice with all of this, which is totally cool. And we'll make sure that we get solid about this over the next couple of days. All right? So we're going to pause right here. We'll finish up the next video with the last part. But as always, keep up the good work and good luck. We're all counting on you.